So now we are going to see the final class for students T distribution. We have already seen, I'll also open that sheet. We have it, I hope. So you have already seen how t-test will be happening and what are the things we have to do for those t-tests, right? I'll take that, the t-test sheet. This will be the continuation of what we have seen in the t-test. We'll be calculating the t-value by using that formula, right? So this is the thing, right? So it will be given some data set where you'll be having a distribution before applying some conditioning and after applying some conditioning, right? So for example, here we have blood pressure before a particular treatment, and once a treatment is applied and oral treatment is applied, the distribution is actually changed. Now how the change will be there, that we have to see, and those changes we have to reflect in my t value, right? So now you'll be given some other methods also, some questions like for example, I'll have this problem one. The average number of customers buying a particular product is around some 160. Average number of customers buying a particular product is going to be 160 with a standard deviation of, standard deviation is nothing but how in what interval they are actually splitted out, with a standard deviation of say 8.62, right, with a standard deviation of 8.62, and the number of customers, number of customers is, say for example, I'm going to have some 10 customers, right? Now what we have to find is, find the error around the mean, the error bound around the mean. So we have to find this. So what is that error bound around the mean is nothing but how the mean value is going to be deviated from this 10 customers. If I add some additional number of customers, how those their values will be differed, right? Like that I have to find. We know that a distribution after applying some conditioning, if it is going to change, then the change can very clearly be estimated in students t distribution, that is t test. Many tests are available. The first test what we are dealing out here is the t test. So now we can apply t test for it. This is actually, this error bound around the mean is actually shortly called as EBM, right? Now we will see how to find EBM, right? Now, for finding EBM, we first need what is the t value, right? Now, we need what is the t value, right? Sometimes confidence interval will be given in the sum itself. I can also state here with confidence of, or we can say with 95% confidence. I say with 95% confidence, I have to calculate the error bound around the mean. So, what is that error bound around the mean is nothing but, I'll open this. Yes. Take the pen. This error bound around the mean is nothing but I'll have an axis and I need to have a distribution of the data over here. And the error bound around the mean is finding the bound for which the mean will actually travel. I say that mean will be ranging between these values only. My mean value. What is the mean value? The mean is a point that represents the entire distribution in a single number, the central tendency. So where my mean actually lies, in whatever changes I do in my distribution, it may change or it may not change, it may decrease or increase, and how my mean will be distributed, I have to find. So I need to find this particular value. Say I say this is going to be some lambda and this is going to be minus lambda. If this is going to be the origin, then I need to find this distribution actually. So these are actually the values which I normally reject because they are actually some red values which I no need. Only the gray values I will accept. Right? These are actually called as error bound. Right? These are actually the error bound. I can find these error bound by using the t-test. Right? Now what I will do, first I will take the standard deviation. So what is the standard deviation here? Please be unmuted. So this is more important. You'll be having quizzes also based on this only. So please be unmuted. What is standard deviation here? Yes.
8.62.
Yes, standard deviation I call it S is equal to 8.62, and sample size. Sample size is is equal to 10. Why I say 10 is I have 10 customers, so sample size is 10. And immediately after writing sample size, you write the degrees of freedom. So what is degrees of freedom in t-test is nothing but if sample size is going to be n, I say degrees of freedom is going to be n minus
Minus
1.
1.
Great, n minus 1, that is n minus 1. Rightly pointed out, so it is going to be 9. Right, one more value we have, that is the mean. So average number of customers I have, that is the mean. So mean is equal to 160. So these value I currently have. So now what I have to find is I have the confidence also here. So I state the confidence here. Confidence is equal to 95 percentage. So this is my confidence interval. Now what I have to find, I need to find the EBM value, that is error bound around the mean. So if I want to calculate the error bound, I need the t-test values. So first we will write what is the formula for that error bound. Then we'll go into the t table and find the t value for the 95 percentage confidence. So EBM will be equal to, the usual formula is you find the t value for, let me write it in the subscript way. Yes. T of, I write the degrees of freedom as either a mu, or I say it is going to be degrees of freedom as v comma alpha divided by 2. I say it alpha, I take from the symbols on it. Beta is it alpha divided by 2. So this alpha is nothing but the confidence, right? I'll take the confidence. I have the confidence separately. We will take that confidence, and this will be multiplied with a fraction, that is standard deviation divided by the number of samples. So, okay, I'll take the equation again for a fraction. Standard deviation divided by square root of when. Yes, this is actually the formula for EBM. Right, this EBM says that it is actually going to be surrounding the standard deviation divided by the sample size. Right, actually it is actually if you take variance, you take put square root for everything. Otherwise, you take the standard deviation. Now we will see what to substitute for this is this thing. This is nothing but the t value for the appropriate degrees of freedom v and confidence interval alpha by 2. We take alpha by 2. Why? Because we are going for a two-tailed distribution. If you are going to take two-tailed distribution, you take alpha divided by 2. Right? So now what is my confidence interval? First I take this t by 2. I take this copy. Yes. Yes. Now this is actually going to be equal to, what is my degrees of freedom here? My degrees of freedom here is going to be 9. And what is my alpha value? You see here, what is my alpha value? I have 95 percentage confidence. What is see my alpha value? What is my alpha value? My alpha value is actually my 95 percentage confidence interval. So here itself I can write it clearly. So I take the alpha. So if it is 95 percentage confidence, I need to take 1 minus 0.95, that is going to be 0.05. That is going to be my confidence in the T table, because if 95 percentage in the sense in T table I have 0.05, right? So this is 0.95, that is the confidence 0.95, the confidence interval. So what is it? I have 0.05. I come here, it is alpha divided by 2. So 0.05 divided by 2 I have to write. So I write it 0.025. Or I can write first as 0.05 and again I write it. This is going to be 0.025, right? So in the t table, I need to see the value t of 9 comma 0.025. Now I go to the t table. You say me what will be the value. See the t table where I have to check now. Please unmute and say me where I have to check now. What is my value? What is my value in the t table? My confidence interval is 9, sorry, my degrees of freedom is 9 and the alpha by 2 value is 0.025. So what will be my t table value?
2.26.
2.262, very good, 2.262. So I write that is equal to 2.262, right? Now I go to the EBM and substitute my values. I got my t values ready. I go to my EBM. So this I'll take. So now I substitute. What is the t value entirely here? As Sandhya said, it is going to be 2.262. And what is my standard deviation value? You go above and see what is my standard deviation value. I got 8.62 as my standard deviation value. And what is n? 10. So I take that. So I'll put here 8.62 and this is 10, right? Okay, now coming into the play here. So here I have a 2.262 into 8.62 divided by root 10. So what will be my answer? I take the calculator.
6.165.
So we calculated it. What is
6.165.
Yes, calculator, right? Yes. Now this is my EBM value. Now what is my, then what I have to write? Where my mean actually lies? My mean will actually lie between, so I'll take my mean value. Mean is equal to 160. So the mean lies between 160 plus or minus. I need to write plus or minus instead. I'm searching for plus or minus. Where it would be here. Yes, it is here. 160 plus or minus 6.165. So this is the value. Either it will lie 160 minus 6.165 or it will lie 160 plus 6.165. Now in the question I'll be asking, if the mean value is going to be 168, will you accept by my hypothesis or you will reject my hypothesis? My mean value I'm saying 168. Now you will accept my hypothesis or reject?
Reject, sir.
Great, that is the thing. And in my question, I'll be asking like my mean value is going to be 150. You accept my hypothesis or reject my hypothesis?
Reject, sir.
Yes, reject the hypothesis.
Reject, sir.
Great. Now this will be the questions type, right? Now this is will be clear, right? Now the questions will be like one mean will be given, standard deviation as well as the number of customers. Confidence interval may vary, right? If it is 90, what will we do? What will be the, if it is 95%, what will be the case? What will be the change if I put 90%?
0.1 will come, sir.
0.10, and what is alpha by 2? 0.05, right? So that will be the alpha by 2 value. So I'll search that in the t table and then I'll write. Yes, this is very clear, right? These type of questions you can answer with time is only 1 minute or 1.5 minutes. You have to calculate what is EBM, and based on that EBM, either you'll be asked EBM alone or you'll be asked with some values either to accept or reject. You just say accept, just tick accept or reject, right? Is it clear, right? Is it clear?
Yes,
Yes,
sir.
sir. Yes,
Yes.
sir.
So to mislead you, there may be some other choices, maybe some other options like cannot predict, or none of the above, or can predict only with other variance values like that. But you just see that the thing is either accept or reject. So what you have to keep in
Sir,
mind, if standard, let me finish. If standard deviation and the alpha value is given, you can easily finish, right? And the sample size is also needed. Yes, now you can ask, Nasim.
sir, T means what, sir? There.
Yes, T is actually the T table value. T table value. In the T table, in the degrees of freedom V, and in this particular significance level alpha, check the thing. Why I do alpha by 2 is I going to have two tails. So if you see in my paint window, I going to have two tails. One is over here and other is over here. So totally two tails are there. So alpha by 2. If it is going to be one tail distribution, you can have only one tail. One don't one divided by 2. I'm making it clear. No doubts, right? Yes. Shall we proceed? Shall we?
Yes, sir.
Yes, sir.
Yes. Now, one more thing to ask you. If a distribution is given to you like this, a distribution will be giving either 10 samples or 20 samples, or from 1 or 20 samples and 10 or 7 samples is given. Now, what will be the method here to find the t value? This is actually t statistic, and this is actually t table value. You should not be in a position to confuse between what is this t table value and what is this t statistic value, right? This statistic value is actually having the formula calculated from the particular thing. So now if we got some 3.32, and I say this based on this, my values may range. If I get the t statistic, then what I do, I go to my t table, and here what is my confidence interval in the Excel sheet? Sorry, what is the degrees of freedom here? My totally 10
Nine, sir.
samples.
Nine,
9.
sir.
So in the ninth way, where is 3 point something will range. In the t statistic, what is my value? 3.324. In the ninth interval, where 3.324 will range. I think here 3.324 will be ranging between 2.896 and 3.335. That I will sorry, I must here, right? So sorry, 9 is here. 3.324 will be above 0.005. So it will be on the right hand side of 0.005. So that is actually the thing, right? Once you calculate C statistic, using that you can also proceed for this particular p value, right? There should be a difference between calculating t statistic as well as the t table value, right? Now I'll go into another problem. This particular word file I'll also share you, and this is the final thing yet to share today. I said right, today I'll share, that is the thing, and all other things were shared, right? And the revision also will be done today. Second problem, the number of people coming for gaming companies is 20. Number of people. The average visits for a product is average visit for the product is average number of investigation on that particular product is going to be around some 82. Average number of visit is going to be some 82. Next, I also have a standard deviation. Standard deviation is 4.83. Compute the error bound around the mean with a confidence of 90 percentage. Right? Can you guide me in the steps? How? What will be the first steps to do? What is the standard deviation here?
4.83.
4.8.
4.83.
0.83. Great. Next, number of samples
20.
20. Next, degrees of freedom V is equal to
10 minus 20 minus 1.
20 minus 1, which will be 19. Next, I want this particular mean value. Mean is equal to 80. Now I have everything ready. Finally, confidence interval. confidence interval is going to be 90 percentage. So now I can calculate the alpha, that is significance level. Alpha is nothing but significance level. Better we can write that. Now significance level alpha is equal to 1 minus 90 percentage can be written as 0.90, and as Narasimha said, it is going to be 0.10. Right now I got everything ready. Now we can proceed into the formula for EBF. What is EBF then? EBM is equal to, I take the value. Now first I have to compute the T, and T of V, comma, and alpha divided by 2. Here also I'm going to go for two-tailed. So if I go for two-tailed, I can take alpha divided by 2. Clearly asking, saying in the question, if I say single tail, what you should take? You should take only alpha. In the question, if I didn't say single tail, you go with two tail. Okay. In the question, if I ask a single tail, you should not take alpha divided by 2. Just take v comma alpha. If I directly specify as two-tailed, or if I didn't specify anything, the default is two-tailed, because there'll be a mean value either before and after. But for some features, only one range will be there. The negative range will not be there for some features. Say for example, age. For age kind of features and all, if it is closer to 1 or something, it may not have the negative age. If the age value is around some 20, 30, then negative I can put. But if it is closer to 0 or 1, sorry, age cannot be 0. If it is closer to 1 or something, I cannot have a negative age. In those cases, I'll be explicitly specifying in the problem as single tail. In that position, you should not use alpha divided by 2. Right? Keep in mind. Right? Now we go into the formula. This. Right? S divided by root. What will be the p value now? What p value I have to take? Can you say? P of what will be v and alpha by 2?
T19, 0.0.
Oh, you are saying 0.0?
0.050.
Okay, you are saying the final answer. So 19 comma 0.10 divided by 2, and like you say, it is going to be 0.05 is equal to 19 comma 0.05. So which will be equivalent to, I go to the T table, where is 19? Here it is 19, and in 19 I should take 0.05. So what is the value?
1.729.
1.729. 1.729. I write it here. Now I again go to the EBM value. I just substitute. I have all the values ready. Now I can calculate the error bound. And what is the value here? Total number of samples is 20, and standard deviation I think
83.
is 4.83, and over here it is going to be 1.729. 1.729. So I will calculate the value of this.
1.867.
1.867. Okay, 1.867. Now I take my mean distribution. Mean is equal to 83.
82.
82. Mean is equal to 82. So the mean ranges as 82 plus or minus, that is plus or minus, I have to take this here, mean plus or minus 1.867. Right now, if I give this, now I'm asking a question. I go up. the mean people visiting the product can be 79.23. Next, the mean people, sorry, mean is not a good word. Usually when we say it average in English. In machine learning, mathematics you can say mean as average people visiting the product can be 81.32. The average people visiting the product can be 85. Accept or reject the following hypothesis. Right now, whether you have now the first hypothesis is some people are saying that average people visiting the product can be 79.23. Now you have found already the EBM value and you have said how the mean will range. Now will you accept this hypothesis or you will reject this hypothesis?
Reject.
Reject, sir.
What is the acceptable value range? The acceptable ranges are what is the acceptable range? 82 minus 1.8 is 81. 80.1. Is it correct or am I going wrong? Is it correct? 82 minus 1.867, 80.133 and 83.867, right? So this is the acceptable range. So the hypothesis is rejected. So the hypothesis is rejected. Next, this is
Accept, sir.
accept the hypothesis. Because it is within the acceptable ranges, so I accept. Next, another people are predicting and saying that it can be 85.
Reject, sir.
Reject the hypothesis because it is greater than 83.567. 83.867. Reject the hypothesis. See, now I have written here all types of questions here. Now the first type of question is given some mean, standard deviation, number of samples, confidence. With this, I will be asking you what will be the error bound around the mean. You can calculate by using the formula T of T with the degrees of freedom and the significance level into standard deviation divided by root of number of samples. That is actually a one-tailed value. And when if it is one-tailed value, I don't want alpha divided by 2. And this is one type. And the second type is I'll be giving the level. And based on the level, I'll be giving a hypothesis also for the mean value. You have to say me whether the hypothesis is accepted or rejected, right? This is two ways of calculating given the standard deviation, number of samples and mean, this particular mean. Now I ask you a very clear question. If you are able to answer this question, then you are great. In the given problem for calculating the error bound around the mean, you are given with the mean value and you are given with the standard deviation value, right? You are given with the mean value and you are given with the standard deviation value. Is it enough to compute the EBM or not? Standard deviation is given, mean is given. Is it enough to find the EBM or not?
No, the samples is also in
Yes, number of samples is not given, right? Number of samples is not given. So you just say the number of cannot. There'll be questions like accept, reject, or data not sufficient, or like that something. What you will select? You should be in a position to select not sufficient. Am I right?
Yes, sir.
Yes. So those things you keep in mind. So with now in this class fully I'll be saying in what are the ways you should encounter t-test. So the first way is actually this particular way. But this is actually a bigger way where you'll be given a table like this. This number of samples are is optional. The table will be like this alone. This alone will be given to you. This particular table alone will be given. That is a distribution before applying some treatment or after applying some treatment, or before applying some particular bias or after applying some particular bias. Before or after something, it will be given. What will be the change in the distribution? We have to find. Or for example, the real case in machine learning algorithm is will be given with a result before applying a particular iteration or a learning rate, or after applying that learning iteration or after applying a bias or something, how the accuracy is going to improve. That is what the t-test actually say in the statistic. If this is given, what is the steps you have to do? Find after minus before, so the square the difference, find all the sums and mean and apply in this particular formula. The formula is also pasted here. That is a summation of d divided by square root of n into summation d squared minus summation d the whole square divided by n minus 1, the whole square root. Nothing but I have taken the standard deviation formula. That is the sum of difference divided by standard deviation of the difference we have taken, right? So this will give you the t statistic. And this t statistic, you take my degrees of freedom here is going to be 9. And with this degrees of this t statistic I find the range where my t value will actually lie. In this range, I will be seeing where my t value will actually lie, and I say my p value. Otherwise, if I ask only you the t statistic, just write the t statistic or select the t statistic in the options. Right? This is very clear, right? 3 varieties of t test statistic. It is clear. This is variety number 1, where you'll be given a table and you need to calculate the t statistic using this formula. Whether variety 1 is crystal clear, understood? For everyone I'm asking. It is not that anyone can say yes sir. Not everyone should say. Even though you are a very good topper and more intelligent, please say yes or no. Whether this particular, what will be given is, I'll say one more time, a table will be given. Before applying some bias over the distribution and after applying a bias on the distribution, what you have to do is take the difference, square the difference, calculate sum of all, mean of all, then apply in this formula. Here, what is this summation d? Summation d is this. I have the summation of the difference. Next is whole square root of n into summation d squared. I have the d squared here ready. So this is d squared 418 and this is my n value. And minus summation d the whole squared. This is summation d. This to the whole squared I will do. Whole divided by n minus 1, that is 10 minus 1. So this is what is present in here also, the Excel formula, and the formula will appear here also. Right? I have in my video, if you go and see also, the full explanation will be available. Right? So this is case 1. In case 2, what I will be doing, I'll be giving you the mean, I'll be giving you the standard deviation, I'll be having the number of samples and the confidence interval. Right? Here in this CA, you will be not having the confidence interval because you are the person who are going to find the significance level here. But here the confidence interval will be given and you can find the significance level based on it is going to be a two-tailed or one-tailed. Default is going to be two-tailed, right? So you apply in the error bound around the mean and calculate the mean value. And this is more the third case that is most important and quickly you have to answer within some 30 seconds or something is this. This will be given accept or reject. Select the option correctly. If you find this EBM wrong, then it will be wrong, right? And you may think sometime, right, if it is going to be a round off value or something, and if I give this going to be some very closer value, then you may think whether it is accepted or rejected. I will not give the value that much close and all. Right? I'll be giving a nominal round off value. So I don't think that if I round off, I don't know whether to accept or reject. I will not give that much closer values. Some lenient values will be given. Right? So now, keeping the t-test in mind, now this Word file immediately I will save and I need to immediately I'll post it in the Google Classroom. For convenience, I'll be opening the assignment or the partial correlation. This is very clear. Like this is also most in the maximum number of questions tomorrow is this only. So if you are ready with this only, you can attend. Because if you study this itself, you will be passed. So you just to see this very clearly. One of the most important topic in machine learning. So you see this, right? So anyone have any doubt in these formulas and how to do this partial correlation and thing? You will be given the table like this. I'll be giving you x1, x2 and x3. These three things I'll be doing. I'll be giving. You have to find x1 squared, x2 squared, x3 squared, x1 into x2, x1 into x3, x2 into x3 you have to find and apply in the formula. I'll be asking you to find the correlation between x1 and x2. You should understand that yes, correlation means R. I need to find the correlation between x1 and x2 means R12. So I use in this formula and calculate this and I'll do this. Right, for this and all, I'll be giving more than 2 marks, not just 2 marks, more than 2 marks I'll be giving. R12 you should calculate, R13 and so on. Right, if you see in the assignment, the recently shared assignment, if you give, I have given like calcium, phosphorus and milk quality. You consider this as x1 and this as x2 and this as x3. Right, now I ask you a question. I want everyone to answer. Let me see who is going to answer. Find the correlation between calcium and the phosphorus. What is the notation for that?
Summation x1
R12.
by root of
R12. Very good. R12. Same thing I am, and they find the correlation between calcium and phosphorus by keeping milk quality as constant.
R12.3.
R12.3.
R12,3.
Right? Very good. Now find the correlation between, find the correlation coefficient, that is multiple correlation, that is like for the dependent variable milk quality by keeping calcium and phosphorus as independent variable. What will be saying?
R1.2.
Milk quality as dependent variable, calcium and phosphorus as independent. R
3.12.
Great, R3.12. Right, for these quizzes, I also specified the R values also. So in order to not make you confused, but in sometimes in exam, I will not give the R values. You should understand what is R. But I'll give the notation 1, 2, 3, those and all I'll give. Based on that, you should calculate. Right, so these formulas are clear, right? So you have in mind all these formulas alone. Right, if these formulas are ready, you will be thinking, right? So how to find R12.3 and so on. Don't want to go into this second order in calculation, but memorize the formula for quizzes. But within 2 minutes or 1 minute, we cannot calculate for R12.34 and all. So you can calculate. So you'll be having these formulas in mind. Formulas will be asked, but problems very rare. Okay.